Hi, good morning. Welcome to Pole Shift News. It's Jim from the mavestar Observatory. Guys, in this video we're going to talk about the argument, which is, I think, the most important argument of this era, and that is CO2 related to global warming, or climate change as they now call it. So, just to give you a few ideas of why we're going to get into this, well, you probably have heard of Extinction Rebellion, claiming that there'll be 1 billion people die in the next 10 years as a result of rising CO2. I made a similar claim in a video that I put up yesterday, but only the reasons were slightly different to that of Extinction Rebellion Group, which is an organisation now which is trying to put pressure on the government to reduce its CO2 emissions to zero by a specific time. We've also seen in the media, is it the Swedish girl, Greta, making a very emotional plea to the European Union to cut carbon emissions. So, in this video, I want to go through a few basic facts that support their argument for CO2, and I want to give you an alternative to those, and leave it with you to decide which you believe is more accurate. I will say this though, that over the course of probably the last 30 years, there has been trillions and trillions of pounds raised as a direct result internationally with regards to the rising CO2 and trying to combat the amounts of CO2 that we put into the atmosphere. So before we get into all this, guys, I'm pretty sure now you're pulling yourself up on the chair and dashing off quickly to make a cup of tea because it's going to get really interesting. I just want to say a big thanks to those people that support our observatory here. There's probably three main things which we're going to get to a little bit later on in this video when we have a look at a flowchart that we cover directly at this observatory. That is the Earth's magnetosphere, the Earth's migrating magnetic pole, which is the rare anomaly that last took place 780,000 years ago, and the other one is soon to come online, the study of global cosmic radiation. So if you want to support what we do here on this at this observatory and on this channel and at the website, there's a link down there that you can do so. So let's get into it. Of course, we're looking at a chart that shows us 800,000 years of the carbon history, and as you can see, and what they will say is that it has remained at around 200 to 280 parts per million for nearly 800,000 years, and recently that has gone up twofold to 400 parts per million in the recent times, and they're saying that it is this that has led to global warming, which they now call climate change, because they do accept that in some parts of the world it is cooler and in other parts it is warmer. So in their argument, they say in the last century or the last 100 years the Earth has warmed by at least 1.2 to 1.4 degrees Fahrenheit. CO2 is trapped by solar radiation, and this is what's led to the term greenhouse gas. Another fact is that since 1998 to 2005 was the highest in the last century recorded warmest days or years, sorry. And another fact is that CO2 and methane are at the highest in the last 400 years. So it's not just carbon CO2 that's increased, it's also methane. They say that the Arctic sea ice is shrinking and declining in the last 30 years by 10%, and they believe that by the end of this century it is predicted that the Earth will warm between 2 and 10 degrees Fahrenheit. Now, humans contribute around about 30 gigatons of CO2 on average every year. But the Earth, the land and the oceans contribute to the atmosphere around 780 gigatons every year. But to say the Earth was in balance, and we'll go to this chart now that we're looking at, for 800,000 years, and that over those 800,000 years, although 780 gigatons per year was put into the atmosphere, 780 gigatons was also absorbed by natural means, either via the Earth or the oceans. So what they're saying is that in recent times we have shifted the balance of CO2 in the atmosphere and we did this over recent terms, and the reason for that is since the Industrial Revolution we have added more carbon through burning fossil fuels, using cars and increasing our technology. So I've got, first of all, I'm going to show you the flow chart of what I believe is really taking place later on in this video, but I've got a few issues with the data that they're showing us. First of all, I find it strange that recently on this chart, just at the end, it spikes an extra 200 parts per million. I do wonder about the accuracy of that increase, because if we go back 800,000 years, there is no increase measurable to that level. And if CO2 is responsible for global warming, then if we only go back 12,000 years, how do we explain we came out the last glacial period, 12,000 years? Humans wasn't in the Industrial Revolution at that point. Let's go and have a look at a chart, first of all, that shows us where we was during the Industrial Revolution, and have a look at temperatures with relationship to that. So here we are, we're looking at the sunspot numbers that date back to the 1600s, and that's good enough because, as you can see, I've marked where the Industrial Revolution was in 1760, and my argument here is if CO2 began at 1760 and as a result of increasing CO2 we have now warmer temperatures on this planet, it doesn't seem to match with what the trend we're looking at. And the reason for that is there's a couple of things. First of all, after the Industrial Revolution started in 1760, we go to the beginning of the 1800s, we'll see that the temperatures are dropping on the Earth. And that was a time known as the Dalton minimum. If we're increasing CO2 from 1760 to this modern day, then why did the temperatures globally fall during the 18th century? Another question is, if we go back to 1650, temperatures was described back then, and the period of time was classified as the Maunder minimum, but it was described as the Little Ice Age, and the temperatures were very low, to the point where even here in the UK the River Thames froze up, and you've seen the pictures of market stalls set up on the River Thames. So in 1650 it was considerably cold. But what was it then that brought us out of the Maunder minimum? Well, it can't have been the Industrial Revolution and the increase in CO2 at that point, because that wasn't to take place for another 100 years or so, or 60 years or so. So what was it then that brought the temperatures up of the planet dramatically to the point of 1750, or from the 1700s to the 1780s? It wasn't CO2, was it? What we see in this chart is something a little bit more true to the nature of how climate changes on this planet, and we can see that when we endure more sunspots or we have a greater solar output, we do for reasons that really we should accept and seem more natural, enjoy warmer weather as a result of that, or warmer periods. What we have recently experienced is a modern maximum, and they have admitted that over the last few years at least, temperatures are starting to decline, and we will have a look at the ice in the Antarctic region, sea ice, and you will see that there isn't much of a change in that with regards to a shrinking effect, at least to the point where they claim it will be a 10% loss. We're not that far off the average over the period of time. And what we've got to also incorporate into this model is inertia. The Earth is a very large body out in space, and it's a bit like, to use the analogy, if we switch on the kettle and boil the water and make a cup of tea, and we put the cup of tea down there, it doesn't instantly go cold as a result of no longer being boiled. It takes a period of time for it to cool down, and the Earth is a massive inertia, and likewise it has got to take time to cool down, but we are starting to see the effects of it cooling down. Another thing is that we are due to go back into a glacial period. I'll show you quickly on a chart how close we are to going back into a glacial period. So according to thousands of years of watching interglacial and glacial periods, we are at the bottom of the chart, which states it should be cooling and going back into another glacial period. Now, if CO2 is at its 400 parts per million right now, and has been responsible for global warming, then surely we should not be anywhere near another glacial period. But if we look at the comparison between sunspots and the last glacial period, you'll see that when we came out of the last glacial period 12,000 years ago, we have cooled from that point on, and as a result the sunspots have declined from that point on, indicating that we should be moving now back into another glacial period, so the Earth should be cooling naturally from this point on.
So as you can see on this chart, it goes back 13,000 years, so you can see that just around 12,000 years ago we was experiencing a lot more solar activity than what we was, and that was probably responsible for bringing us out the last glacial period, but from that point on it slowly declines. This could be an indication that we are moving back into another glacial period, and you would expect that temperatures would slowly decline from that point of where we experienced a lot more sunspot activity. So on this chart we've got two dates that are very important that they use to claim CO2 is causing temperatures to rise. First of all, we've got 1998, which was, as they say, one of the highest recorded years of temperature. So the temperature during 1998 was very high, and higher than it was over the last century. The other date that is significant is 2005 that they use. But you can see that from 2007 it's almost though we have passed the equilibrium point of this rising temperature, because you can see that CO2 continues to go up and up, and yet temperatures go down and continue to go down. And it'd be interesting to see what the temperatures are over from the period of 2007 to the present day 2019. I could probably find those, but I do suspect that there is some tinkering going on, and I have heard some stories about the stations where these are actually collected, and I think you have to ask serious questions of whether you should put a temperature station in places where they have been putting them, because I think that there could be random uncertainties of external heat sources affecting these, and in doing so giving a higher reading than normal. But that's an argument for another day. The point is this, is as you can see on here, is that CO2 is constantly going up and temperatures have started to go down, and that could be the fact that we have passed the equilibrium point, or the Earth has now caught up with its inertia, and we are starting to slowly cool down globally. If we just concentrate on the chart from the 1950s to 2000, you'll see that we was in a period described as the modern maximum. That's when we was enjoying a lot of sunspots at this period of time. But you can see towards the end of the modern maximum, sunspot numbers drop off, and if we look at the black line beneath the line of average on the modern maximum, you'll see that temperature is following suit. In fact, if we just look from the 1600s to 2000 on this chart, you will see a correlation where it rises when sunspot rises in numbers, and the temperature drops where sunspot numbers drop, and it goes along very nicely, fitting the heights and the lows in terms of sunspot numbers with relationship to temperature. I think this is a more accurate chart of describing what is going on with regards to temperatures than the CO2 chart does, because the CO2 chart doesn't seem to incorporate the peaks in between glacials and interglacial periods for some reason. And I find that very bizarre, because if CO2 is the driver of climate in favour of raising the temperature, then we should see that every time we come out of a glacial period, then we should also see a spike in CO2 prior to that, allowing a bit of time for that inertia, or the temperature to catch up with the inertia of the Earth. But we don't see that. For some reason, if we go back to that chart, we just see a spike in recent times. So when we look at the history of CO2 going back 800,000 years, why do we not see any more spikes? We have had, and we know that in this period of time, many glacial and interglacial periods, but no spikes in CO2. So the Earth was warming for some reason, but it wasn't to do with CO2. The Earth was warming, bringing us out of a glacial period, but we don't see any spikes going back over the 800,000 years saying that it was CO2 related. It's only now they're saying that it's CO2 related. The thing is, if you question climatologists on this matter and you show them this chart, what they will then say is something completely different. And do you want to know what that is, guys? Oh, it's to do with the elliptical orbit around the sun, or it's to do with the angle that the Earth is slightly changes, or something else. They'll completely shift the argument or move the goalpost to another area of science, and therefore we have to start all over again. I think CO2 has nothing at all to do with global warming. You know, the fact that we put 30 gigatons into the atmosphere annually compared to the Earth's natural process of putting CO2 into the atmosphere at a tune of 780 gigatons, it means that our impact in this is very, very small. You know, it's neither here or there. 30 gigatons compared to 780, which is naturally put into the atmosphere by land and oceans, is not really an argument that we have caused a significant rise in temperature. So if it's not CO2 driving the climate, then what is? So over the last 33 years we've had 3 solar cycles showing an exponential decrease in sunspot numbers. On the other chart I showed you, saw when sunspot numbers drop, the temperature drops as well. So there's that, right? Okay, this could be, the temperature now declining on the Earth could be a result of low solar activity. It's more than likely the case, but there's something else happening, guys. We know, first of all, we're in a pole shift, this rare event that lasts, how long, but the last time it happened was 780,000 years ago. We know that the low solar activity, what we're looking at here, can lead to a shrinking heliosphere, allowing more cosmic radiation in, and we also know that we're in a pole shift, and that weakens our magnetosphere, and that in turn allows more cosmic radiation in. So I just want to show you now a flowchart of some of the things we've learned with relationship to these 2 events coinciding, taking place at the same time, that has led to something that's not widely talked about in mainstream press or science organisations, although there is some research being done by how should we describe them, renegade scientists, and they are starting to put the pieces together with regards to what could possibly be taking place with our Earth and why. Together a flowchart, and I'll just briefly go through it. And there's probably a couple of spelling mistakes in there. You don't really need to mention them, guys. It's just mainly just to give you a simple understanding in order of how things have happened and probably why they've happened. So we start off with a low solar output, and that's due to a lack of sunspots. We've got a shrinking heliosphere as we've got low solar activity, so is more cosmic radiation inbound in our solar system. Add to this, we've got a weakened magnetosphere due to a magnetic pole shift. This leads to more cosmic rays in our atmosphere. More cosmic rays in our atmospheres leading to more water vapour seeding in our atmosphere. More water in our atmosphere slows down the jet streams. Leads to wider jet streams breaking down, plus mixing polar jet streams with subtropic jet streams, and as a result of that we get global climate change, which leads to crop failures, crop losses, droughts, floods and cancer. Other things such as cardiac arrhythmias that we've recently found is a cause of extra cosmic radiation, and other things as well. But this will in turn lead to a economic collapse, because when food is affected, as we've seen throughout our history and ancient civilizations, when food affected, the crops were affected by seasonal change. It affected how many people wanted to stay in a city, and also how many people you could feed. So this will probably lead to, if nothing's done about this globally, economic failure across the grid. And the reason why I said that, and the reason why I said that possibly 1 billion people could die in the next 10 years, is not due to the increase in CO2. It's simply due to the fact that we can no longer sustain the people that we've got, or in terms of the amount is 7 billion, we can no longer sustain it because our seasons are changing, our arable land is going offline, and we're already starting to see 10% reduction in the United States. We're starting to see places like India banning its exports of food, China now importing rice from the United States. This is all signs of major changes and major events to come for us all in the future. And if we all are having to work for a whole week in order to pay for just a couple of things to eat, then eventually the system, or the economic system, or the capital system will probably fail. It's a little bit different approach to things, but I think when that guy running Extinction Rebellion is probably right, with the terms of numbers that are going to be affected by it, I think it's likely. And I think it's likely not due to the rise in CO2, but the actual climate change that we are going through. So, guys, I just wanted to spend, a little bit of time perhaps putting all this in order, because, when we talk about these things, it's a little bit more difficult than when you actually see them laid out like this in a flowchart of how things lead to another. And this is probably why climate change is very hard for people to understand, is because there's not just one factor or one anomaly causing it. We've got two anomalies here that do the same thing and probably compile with each other. We've got the magnetic reversal taking place, weakening the magnetosphere. There's serious risks to every inhabitant on this planet as a result of just this on its own, because we're not sure whether the Earth is going to complete its reversal. We're not sure it's going to be an excursion event, but nevertheless, this on its own right will at some point reduce the magnetosphere strength down to around 10%, and at that point there will be a lot more cosmic radiation inbound affecting the climate. This on its own has led to, as we've seen in them charts, in its own right, if only this is taking place, this has led to lowering global temperatures. We've seen the Maunder minimum, the Dalton minimum. As a result of low solar output, we get lower temperatures, and as a low solar output happens and takes place, the longer it takes place, the shrinking of the heliosphere continues, and as a result of that we get more cosmic radiation inbound. This is why it's a little bit more harder for some people to understand, so I hope that we've put it in a little bit better context today. But what we do at the observatory is concentrate on three of the main things that are taking place right now. As I said earlier in this video, we're concentrating on the magnetic pole reversal. We're also concentrating, as a result of the magnetic pole reversal, we're going to be collecting data from all over the world with regards to the amount of cosmic radiation that's inbound, and we will also have cosmic radiation inbound as a low solar output continues to go on, or the grand solar minimum as it's commonly called now. So we collect information on the position of the migrating North Pole, how much cosmic radiation is inbound, and also on the magnetosphere strength. And those are the main three concepts of all what's taking place right now on this Earth. So, I think it's well worth supporting, guys. Like I said, and I've said it many times on this channel, we do a little bit more than just talk about these issues. We're a bit more proactive. We're actually building more and more equipment now, more than we ever have done this year, to monitor these things and relate back to you guys, because as you know, your organisations globally are not coming forth with the truth with regards to climate change on this planet, and the reason for that probably is because there is trillions of pounds involved in that. So guys, there's a link down there if you want to support what we do at the observatory. I'll say what I usually do. You have a great week, and I'll catch up with you again at some point. As always, bye for now.